As we study these energy systems, my goal is to cover the following things with you. Energy systems can be quite complicated at a physiological level, but we want to make it more practical based, so this is what we're going to be looking at for each of the energy systems. We want to know how much power they affect. Of course, powerlifting requires your body to operate at a high level of power, but we want to know where they rank in terms of power production for each energy system. We're interested in how long they last. So how long does each energy system last? And then also what the fuel for each energy system is. So what do they use up in the body? What gives them their actual energy? Is the system aerobic or not? So is it an oxygen-based system, or is it anaerobic, which means it doesn't use oxygen? Also, what muscle fibers and what motor units the energy system is associated with. So you've probably heard of type 2 muscle fibers and motor units, where those are the bigger, stronger muscle fibers, and then there's the type 1, the slow twitch, which are better at endurance. They don't get fatigued very well, but they're also not very big and they're not very strong. Of course, as a powerlifter, we're mainly interested in maximizing the performance of our type 2, our fast twitch motor units. And then we also want to know how each system recharges. So what happens when they get tired? How long does it take to recharge? What goes on when that system recharges? So let's start off. First one, and most pertinent for a powerlifter, is called the phosphagen energy system. It's so named because of the energy, the fuel that's going to be used is various forms of phosphates. So here you can see somebody doing a shot put. That's one of the common examples of it. So anytime you're just doing a very massive explosion of power, you're going to use your phosphagen energy system. It doesn't last very long. If we take a look at the duration over there, 0 to 6 seconds full power. So it's a short burst. Think of driving on that bench press, pulling up on that deadlift. You know, if that lift actually takes 5 or 6 seconds, you really don't have much chance of being successful with that. It can last until about 30 seconds, but if we chart its power, after 5-6 seconds, it's going to start to diminish, and by 30 seconds, this energy system is pretty much spent, and you really don't have too much left to give. The fuel for this is ATP, adenosine triphosphate, and creatine phosphate. So those are the two fuels used. And the whole goal of energy systems is to convert those products and other products into that chemical form of ATP. That's the chemical form of energy in the body. So both ATP and creatine are stored in small amounts directly inside your muscles. They also don't require any kind of conversion, so one good thing about that is there's no delay. Right? If I need to jump up immediately and do something, if you're going to slam a punch, if you need to dart out of the way, you don't have to charge up your body or let things convert. You're able to do that right off the bat. This is sometimes called the Atp Cp System because, again, of those fuels and its name for phosphagen. And this is the rationale why the supplement creatine can be relatively effective. So if you take creatine, at least in theory, if you have a bigger, essentially creatine fuel tank, so you have more creatine inside your muscles, either for one short burst you have a little more energy, or maybe it lasts 7 seconds or 8 seconds, so you might be able to maintain that power output for just a little bit longer. All right, so that's some key info about the phosphagen energy system. The system is anaerobic, so that means it's without oxygen. So oxygen is not dependent for the phosphagen energy system. One of the key things, one easy way to think if you're in the phosphagen system or not, is can you hold your breath and complete the activity? That doesn't mean you should, but the question is can you? If the answer is yes, it's essentially always phosphagen based. So we can hold our breath when we do a 1 rep max. You could hold your breath doing a 40-yard dash. You can hold your breath when you do a set of 3 on deadlifts. So those are going to be phosphagen-based activities. Phosphagen system, being the most powerful energy system you have, is going to work with your type 2B, some people like to call those your type 2X motor units and muscle fibers. And those are the biggest and strongest muscle fibers that you got. An easy rule of thumb is if you're ever trying as hard as you can, you are using those muscle fibers. Even if your performance sucks, if you're trying as hard as you can, you're going to be using those muscle fibers for sure. Some common examples, we've mentioned a few, but powerlifting and Olympic weightlifting, anything where you're hitting that 1 RM is going to be pretty significant. A 40-yard dash, a 100-meter dash, 200. If you think, what are the records for those things? Well, people can do a 200 in just under 20 seconds, a well-trained individual. So that's less than 30 seconds, and there is no pacing yourself. If you run a good 200, you're supposed to just go flat out the entire time. But no one in the world can run a 400 flat-out sprint because it can't be done in less than 30 seconds. They just just don't have the energy for that. Other things like a knockout punch, pitching a baseball, like throwing a fastball, doing a maximum long jump, a maximum vertical jump, or slamming someone in wrestling, all of those would be really like single effort, high power output, phosphagen based activities.